Hi guys, welcome back. So today we're going to have a look at some of these projectile motion questions, because I think this was one of the lessons that was sort of towards the end of last term. So I think some people have sort of gone through it and some people are still a little bit confused about what to do. So just to quickly review what projectile motion actually is, projectile motion is this idea, like for example, if we were going to throw a ball, if we throw the ball up in the air, when we first throw it, it's got a lot of energy, a lot of kinetic energy from the thrust from our arm throwing the ball up into the air. But then because of gravity, as well as the friction because of air resistance, that starts to slow down. And then eventually it reaches that sort of tipping point where it begins to sort of fall down back to the earth again under the result of gravity. So we've got our influence here, or our force here, due to gravity, which is causing the ball to fall down, as well as that air resistance. So if we were to throw something, we were going to be throwing it at a particular angle, and that's this value here, A, and we're also going to be throwing it at a particular initial speed. So this is this value here for velocity V. So if I was to throw something really, really hard up in the air, it doesn't matter how hard I throw it, it's still going to slow down and then return back to the earth. So this initial velocity is really the only value that we're interested in, because I know that the velocity is going to change as I go through this particular parabolic curve. So there's a few different sort of formulas here. So I've just popped them up the top of this page. So if you wanted to go through and review those, they are in your textbook in that section 4.6 projectile motion. So let's go through just a couple of examples here. So for the following questions, give you answers to 2 decimal places where a decimal answer is required. So a soccer ball is kicked off the ground at an angle of 67 degrees and 23 minutes with an initial speed of 13 meters per second. So calculate time of flight, the range, and the maximum height reached. So if you just go back up, this is actually a pretty simple question. I know it sounds kind of crazy, but all you're doing is you're taking the formula, you're going to substitute in the values that you know, which was the angle and the initial velocity, and then you're going to find the unknown variable. So for us, the first one was time of flight. So this equation here. So let's go ahead and let's show you how to do that particular question. So I've already written the formula down and I've written the information that I know. So now all I'm going to do is I'm just going to substitute that into that equation. So T is going to be equal to 2 lots of the velocity times by sine of the angle 67 and 23 minutes. Now there's a really easy way to do this in your scientific calculator. I haven't quite figured out how to do it in the graphics calculator yet, so I might just have a play with that and see if I can get that to work. Okay, so I think we have to go into, first of all, we're going to go into run matrix. So let's just clear all this stuff. So this is from our previous videos, if you want to go back in and have a look at those. And then I think we have to go option and then scroll to angle. Yeah, and so these are this is our degrees, minutes, and seconds buttons there. So if I wanted to type that in, I would just type in sine of 67 degrees and sorry, what was the value? Is it 23? Yep, 23 minutes. Okay, so that's going to be equal to, oh no, that's not correct because this is in radians. I thought that value was a bit off there. So to change that out of radians, if we go into options, oh wait, no, sorry, shift, setup, and then we change that angle into degrees. Okay, so now let's try doing that same thing again. Yeah, there we go. So this is going to be 0.923 for our particular value for sine. And that seems reasonable to me because I know that 67 degrees is going to be in that first quadrant, and so therefore I should have a positive value. Okay, so good. We did get it to work. Okay, so let's go back to this question here now. So, and then what's the last thing we've done? So we've substituted into the sine A, and then we just got to divide by our force for gravity here, which is going to be 9.8 meters per second squared. Okay, so I'm just going to pop that in my calculator and come back with the answer. So for our solution, we get 2.45 seconds. Okay, oh, by the way, the reason that I know that this is in seconds is because every single one of my units here is in seconds as well. Okay, so let's have a go at this second question now. So this second question is asking us to determine the range of the flight. And again, that was just a formula from one of those top functions from before. So all I've done is I've written out that formula here and I've written all the information that I know. So again, I'm just going to substitute those values in now. So the range is going to be equal to 13 squared times by sine 2 alpha, so 2 lots of 67 degrees and 23 minutes. Divided by 9.8. So again, you can just go into that same little section that we did before to get the degrees and minutes function up in your graphics calculator. And then I'm just going to come back with our answer. So our solution for the range of the projection is going to be 12.24 meters. And again, I know that's going to be in meters because each of my units here are also in meters. Okay, so let's have a go at this third question now. So the third question is the maximum height reached. And again, this is just a simple formula substitute answer type question. So if I scroll over, oops, sorry, wrong way. All I've done is I've written in the particular formula here, and these are all the values I know. And again, these just came from the question and also from the idea that the acceleration due to gravity is 9.8 meters per second squared. So now all I'm going to do is I'm just going to substitute those values in. So the height, or the maximum height reached of this particular projection, is going to be equal to 13 squared times by sine squared 2a. So a was equal to 67 degrees and 23 minutes, divided by 2 lots of 9.8. So the maximum height reached of this particular function, once I substitute this into my calculator, is going to be 8.69 meters. And again, we know this because all of our units so far have been in meters. Okay, so that was question 1. Let's now have a look at question 2 here. So a ball is thrown so that its time of flight is 10 root 3 over g, and the ratio of the range to the maximum height is 4 root 3 over 3. Calculate the initial speed and angle of projection. Okay, so I've written this question down here and I've written that information. I should also write that they want us to find the angle of projection and they want us to find that initial speed or that initial velocity. So from the question, the time of flight is going to be 10 root 3 over g. And I've also written the formula here for that particular function. So what I'm going to do, I know that this value here and this value here are going to be the same. So I'm going to be able to multiply both sides by 9.81, and that's going to remove that particular variable there. So what I'm left with is I'm left with 10 root 3 is equal to 2 lots of v sine a. And again, I can now go through and I can divide by 2 so that I could write v sine alpha is equal to 5 root 3. So I've got that piece of information there. The other piece of information that I had was that the ratio of the range to, was it the maximum height reached? Yes, the range to the maximum height reached is going to be 4 root 3 over 3. So when we're talking about the ratio, really what we're doing is we're dividing one by the other. So we're dividing the range by the maximum height. So when I divide the range by the maximum height, that's the same thing as multiplying by the reciprocal function. So that's all I've done there. And I've written out this here. So this is our function for the range of flight, and this is our function for the maximum height. I wrote m, I apologize, that should be a h there. And I've inversed it as well. So normally it would be written as v squared sine squared 2a over 2g, but because we're multiplying by the reciprocal, I've flipped the numerator and the denominator. So now I can go ahead and I can simplify some of this expression. So I can simplify by removing this particular value here. I can also remove these values here. Now lastly, I can remove sine because this is going to be the squared version. So I'm going to be left with 2 over sine 2a. Let me just double check that. Yeah, because that's going to get cancelled with one of those. Yep, beautiful. All right, and we also know that that was going to be equal to, what was that value from before? 4 root 3 over 3. Okay, so I might do just like a little bit of rearranging here. So I'm going to multiply both sides by sine so that I get 4 root 3 over 3. Sine 2a is going to be equal to 2. And then I'm going to multiply both sides by 3. Oh, should have given myself a bit more space there. And then divide both sides by 4 root 3. So then I'm going to end up with sine 2 alpha is going to be equal to 2 by 3 is going to make 6 over 4 root 3. Okay, so we've got those two pieces of information there. So now what I can do, I've sort of not given myself enough space. 1 second. Let's have a bit more space there. There we go. Okay, so what I can do now is I can use my inverse sine function. So 2 alpha is going to be equal to inverse sine of 6 over 4 root 3. I'm going to substitute that into my calculator. So 2 alpha is going to be equal to 60 degrees. I still had my calculator in degrees from earlier, but you could also express this in radians, and I think it probably would be better to express this in radians. Okay, so lastly, I'm just going to divide through by 2. So alpha is equal to 30 degrees, or if we were to do this in radians, pi over 6 radians. Okay, so I know what this angle in here now is going to be, so I can substitute that information in. And again, I've got my calculator in degrees at the moment, so I'm just going to keep using degrees. So V sine of 30 degrees is going to be equal to 5 root 3. Okay, and now I'm just going to go ahead and I'm going to determine what sine 30 is going to be. So sine 30 has an exact value of 1/2. So 1/2 V is equal to 5 root 3. So I'm going to double both sides so that the initial velocity is going to be equal to 10 root 3. So lastly, what we can do is we can substitute that back into that original expression to make sure that that does work. Just for the sake of brevity, I'm going to skip this step, but you should definitely have a go and just make sure that that value is correct at home. Okay, I'm going to leave that video there, and then I'm going to go through question 4 with you in the next one, because this one's actually a little bit more complicated. Talk soon. Bye.